A 4-inch long piece is cut and folded in half before gluing it together near the bend. Then I unravel the cable ends to fan out the bristles. The new brush is oriented like so. I don't want any of the bristles in the way of the airstream that propels the whip hose, because that may slow it down some. Hot glue is used, but other kinds of flexible glues could probably work. The brush may need to be tied on with string before using other kinds of glue, though. I go ahead and fan out the bristles a little bit more and then cut off any excess glue. The less the brushes weigh, the easier it will be for the air to move them. Alright, it looks good to me. Let's test it. Can't complain about what I'm seeing here. This air whip is brushing the inside of the duct very thoroughly, which is great to see because the whips have been fairly easy for me to use when cleaning the air ducts. There is one small issue though. As the pressure in my portable air compressor goes down, the whips begin to have trouble. You can see here how they stall briefly once in a while, but then the compressor kicked on and the problem went away. Okay, let's see if I can get my new toy stuck inside this gnarly segment of the HVAC duct. It's trying to get stuck, but keeps wiggling loose. I'm pretty sure it can get snagged in places like this, although I wasn't able to snag it for very long during testing. Just something I need to keep in mind while operating the brush whip, even though I tried to make the brush tips without any hooks or loops to get caught on anything. Overall, I'd say this whip worked pretty well for cleaning the rectangle steel ductwork. When the air pressure was below 100 psi, the steel brush tips would sometimes stick together or bind on the tennis ball. But as long as I keep the pressure at 100 psi and the 1/4-inch supply hose at 100 feet long or less, they do just fine. Gluing multiple brushes to a whip with one hose may be a better option. I'll experiment with that in another video. This 1/2 inch Schedule 40 threaded PVC cap will need an adapter, but it should work fine. Standard aquarium airline was just flexible enough, as long as it's around 65 degrees Fahrenheit or higher. I measure and cut the airline about 40 inches long. Next I fold it in half and mark the center. Drilling test holes and scrap material to trial fit the tubing helps me to choose the correct size drill bit. Ended up using a 3/16 inch drill bit, which is a little smaller than the tube. The cap is now marked like so with a dividing line, and 2 holes are drilled close to the ends of the line, without damaging the threads too much. Using a larger bit, the sharp edges of the holes are removed and the burrs are cleaned up. Cutting an angle on the end of the tube helps when inserting it through the hole. Pliers were handy during installation. The tubing needs to fit tightly in the holes to get a good seal. Remember that mark I made in the center of the tube? An opening is cut in the tubing at this point. It's open far enough so it doesn't restrict air into either half when it's folded and installed in the cap. These pieces of plastic were cut to space the opening in the tube away from the holes in the cap. They're stacked and inserted between the tubes like so. Then I pull both whips until the opening is seated and centered on the divider. An adapter was needed to attach this whip to my air hose. Sealed the threads with Teflon tape. I'm careful not to crack the plastic cap by over-tightening. I made the whips extra long to demonstrate one of the problems with too much length. I don't know why this binding occurs, but when my whips of this material are about 18 inches or longer, it tends to happen. I'll start with 16 inches and cut it to finish length while tuning the whip. I eventually shortened this whip to about 14.5 inches, a little longer than the width of the duct. The tubing shown here is too stiff to be a good whip. I bought it from the hardware store for this task, but it lacked the necessary flexibility. My 20-gallon compressor with a max pressure of 120 psi and a pump rate of 6.5 CFM was just barely enough to run this tool. A larger unit with a higher pump rate would be more appropriate. Thanks for watching.